and I'm going to be talking using a PowerPoint presentation. So let me share my screen. Okay, does everybody see my screen?
Mm-hmm.
Okay, so I thank the organizers for the Ethical Society Mid-Rivers for inviting me. It's very exciting to be speaking in Missouri. I think this is my first time giving a talk. So if, you know, there's nothing really good about the current health situation, but it has allowed for speakers to be able to use do online presentations and go to places they wouldn't have otherwise. So I don't really have a travel budget. So it's very exciting for me to be able to give talks at different places, different parts of the country. So my talk is about my new book, my latest book, which is actually my 16th book that I've written. It's the 30th anniversary, actually, this coming month of my writing career, which I really feel fortunate about. It's very hard to get published, but I've been able to find different publishers and write about things I've been interested in for 30 years. So this is my 16th book, and it's about something called synchronicity, which is a term that was coined by Carl Jung, and part of it was his response to the work of Albert Einstein. So we all know Einstein as the father of relativity, different kinds of relativity, special relativity, which applies to high speeds, and general relativity, which applies to gravity. And also, he was one of the first people to suggest the idea of the quantum, which means small packages of energy. The original idea of the quantum is that energy comes in small packets, and Einstein used that to develop what he called the photoelectric effect, which is that if you shine light on a metal, the light is going to be absorbed by the metal in packets and then create an electric current in the metal if the light has the right frequency. And that idea is used today in any kind of digital camera, be it a cell phone camera or a standard digital camera. We thank Einstein for that idea. So he was one of the pioneers of quantum physics as well as relativity. Now we also know him for his emphasis on humanity and humanism, and also on helping others. And he gave a speech, you probably all know this, being an ethical society, but he gave a speech at the 75th anniversary of the Ethical Cultural Society in January 1951, saying, "I believe that overemphasis on the purely intellectual attitude has led directly to the impairment of ethical values. Understanding of our fellow beings is important. Without ethical culture, there is no salvation for humanity." So Einstein was a great humanitarian and was very influential. Now, as time went on in quantum mechanics, Einstein became one of its leading critics. So that's very interesting to see why that happened. Why did he start out as a supporter of quantum physics and all of a sudden become a critic? And one of the statements he made, which was to his friend Max Born, was, "Quantum mechanics is very worthy of respect, but an inner voice tells me it is not the genuine article after all. The theory delivers much, but does not really bring us any closer to the secret of the old one. I'm convinced that he does not play dice." And that's usually shortened as the expression, "God does not play dice with the universe." But by God, Einstein meant the force of nature, or the spirit of nature. Einstein was not, didn't believe in a personal God, but rather believed in a force of nature that is constrained to do certain things, constrained to perfection, because nature must be, in some ways, the best of all possible worlds. It doesn't make sense that nature should be flawed, or if it is flawed, it means that there's nothing better, that nature is the best there is. And any flaws in nature result from the idea that if things were different, they would be even worse. You know, Einstein believed that we're in the best world possible. So he applied that to quantum physics and was very critical of the idea that in quantum mechanics, there's an element of chance. And if there's an element of chance, that means that it's not the best world after all, because if you roll the dice one way, you get one world. If you roll it another way, you get a different world. And he didn't think that that was reasonable. So he based his views on the Dutch Jewish theologian Baruch Spinoza, known also by his Latin name, Benedict Spinoza. And Spinoza said, in nature, there is nothing contingent, but all things have been determined by the necessity of the divine nature to exist and produce an effect in a certain way. So Spinoza equated the divine with nature, the force of nature, and said that the divine is constrained to act in a certain way. So that led to ideas such as deism. And Einstein always emphasized that he believed in the God of Spinoza. He would say, my views are near to Spinoza, admiration for and the beauty and belief in the logical simplicity and the order of and harmony, which we can grasp humbly and only imperfectly. And he gave many interviews where he talked about Spinoza and his belief that nature must have a certain order to it and a certain simplicity. Einstein was also influenced by the views of Isaac Newton, whose work led to the concept of a clockwork universe, meaning that if you know the universe, well, the properties of the universe at any point in time, you can predict the future because the universe runs perfectly like a clock, perfectly deterministic. You just need to wind it up in a sense, and then everything ticks perfectly. Now, another critique that Einstein had of quantum physics stems from this idea of entanglement. So entanglement is a situation in quantum physics where two particles are linked by their properties. And if you measure one object, you immediately know something about the other object. Even if the two objects are miles apart from each other, you still know something about the second object if you know something about the first object. And Einstein thought that that was ridiculous because he thought that physics needed to be local and realistic. Local meaning that if you want to find out something about any object, just look in its neighborhood. Don't look elsewhere, because things travel through space point by point, just like a chain of dominoes. And eventually, a cause creates an effect through intermediate actions that go through space. And a direct action through space that skips the intermediate points is non-local. And Einstein thought that that is not realistic. And Einstein also thought that you should be able to know properties of any object before you measure them, whereas in quantum physics, it takes a measurement before you know the properties of an object. So that was Einstein's second critique of quantum mechanics. The first one was dice rolling. The second was the lack of local realism. So Einstein called entanglement spooky action at a distance. So he once again, to Max Born, who was one of the founders of quantum mechanics, Einstein gave a critique that said that he didn't like quantum mechanics because it emphasized spooky action at a distance. And it's interesting that he used the word spooky, which suggests the world of ghosts and spirits. Well, the reason Einstein used that term is because he was often criticized and confronted by people who believe in the paranormal and told that relativity has elements of the paranormal. Why? Because it involves a fourth dimension. It involves things that involve very long distances through space and time. It puts space and time on the same footing. So some believers in the paranormal thought that relativity could explain things like precognition, knowing things in advance through your dreams, telepathy, and so forth. So Einstein was often confronted with believers in precognition and telepathy, and Einstein was dubious about that, but he just kind of expected it. And then with quantum mechanics, he saw it as a case where physicists themselves were saying that things can take place over a distance without intermediaries. And that's why he called it spooky action. He said, physics should not be telepathy. It should not be clairvoyance. It should not be the paranormal. It should be solid facts that happen from point to point and that don't require measurements to exist. They exist independently and objectively. Now, there was a famous headline in the New York Times in 1935 where, looking at a paper that Einstein wrote with two colleagues, the headline said, Einstein attacks quantum theory. So it set it up as a battle between Einstein and quantum theorists. Now let's look at somebody in a completely different field, Sigmund Freud. Freud, like Newtonians and like Einstein, believed in a kind of determinism. But instead of a determinism based upon things happening in a chain reaction from time to time and place to place, Freud believed that one's childhood determines one's future life, and that if something happens to you as a child, it will manifest itself later on through dreams, through slips of the tongue, and so forth. So that is called psychic determinism. So a slip of the tongue, according to Freud, is usually not accidental. And there's a joke about that. A Freudian slip is when you say one thing, but mean your mother. I mean another. So this cartoon illustrates the fact that if you say something, you might be revealing something by saying it. And this determinism is contained in the unconscious mind, which is below the tip of the iceberg. The tip of the iceberg is a conscious mind, but there's all sorts of unconscious motivations, according to Freud, which are the result of events from childhood. Now let's turn to two other scientists, a physicist and a psychologist. Wolfgang Pauli, and it's pronounced Pauli because he was originally from Vienna, Austria, so that's the German pronunciation. In English, it'll be Pauli, but I'm pronouncing it the Viennese way, which is Pauli, was a well-known quantum physicist. He was brilliant. He made great strides in his youth. At the age of 20, he published a seminal article about relativity that won him the attention of many physicists. So throughout his life, he was often called the second Einstein, or in German, that would be Zweistein, which means two stones, instead of Einstein, which means one stone. So that was kind of a joke on Einstein's name. Carl Jung was a psychoanalyst, and some people thought of him as the second Freud, or at least he was a disciple of Freud, but he set off in a different direction. He believed in collective unconscious rather than individual unconscious. He believed that cultural ideas can be transported from place to place and time to time, and that ideas from ancient Egypt, for example, or ancient Greece could still be present somehow in our, he didn't use the term DNA, but present in our makeup and conveyed from person to person through a kind of collective unconsciousness. And these collective ideas he called archetypes. So Jung coined the term synchronicity around 1930 in reaction to modern physics. Jung met Einstein several times for dinner in the early 1910s when Einstein was working in Zurich and Jung was a therapist in Zurich, Switzerland. And they had dinners where apparently they discussed ideas in relativity. And Jung became fascinated by the idea that signals and information could be conveyed from place to place in a way that does not depend upon standard causality. Now, standard causality takes place at the speed of light or less, according to Einstein. In Einstein's first theory of relativity, special relativity, any kind of cause creates an effect at the speed of light or slower. Things cannot happen faster than the speed of light in special relativity. So if something happened on Earth, it could not affect a planet near the star Alpha Centauri until 4 years from now, because it takes 4 years for light to travel from Earth to the vicinity of Alpha Centauri, which is one of the closer stars other than the sun. So there's a time delay for causal events. Jung saw a way of getting around that by having acausal events, and that's what synchronicity means, an acausal connecting principle. Now, we have no photos, or I don't know of any photos of Einstein and Jung together, but in the TV series Genius from a few years ago, there was a scene where the two of them met, and this is a snapshot of that scene. So Jung developed an acausal connecting principle and later added to it the idea of entanglement through the help of Wolfgang Pauli, who was a collaborator. And they talked about quantum entanglement being a way of linking things non-locally over a distance. Now, it's surprising that Pauli turned to Jung first as a psychoanalyst and then as a collaborator, because Pauli was a very hard-headed, skeptical physicist. So he was known as being very brilliant and also very, very critical of others. If somebody would give a talk, he would try to find loopholes and flaws in whatever they said, and then during the question and answer session, give them a very hard time. And one of his famous expressions is that a theory was so incorrect that Pauli deemed it not even wrong. It was worse than wrong. He was critical of even famous physicists such as Einstein, and Einstein actually appreciated Pauli's critiques because Einstein would develop theories of everything, and most physicists would just kind of ignore it when Einstein was in his later years, because Einstein just came up with more and more theories in his final 2 decades of life. He just kept producing theory after theory, but Pauli would look at each one and judge them and critique them. And often Einstein would admit that Pauli was right after all. So Einstein appreciated Pauli's critiques. Now, Pauli was most famous for 2 contributions in physics. He made many contributions, but he was most famous for 2 of them. One of them was the proposal that there's a lightweight particle called the neutrino that has no charge, very, very little mass, and can travel through almost anything undetected. And that seemed kind of silly at the time when he proposed it, because no one ever saw anything like that. But then some years later, neutrinos were detected. And the other thing he was famous for is something called the Pauli exclusion principle, that if you have matter particles, such as electrons, they can't be in exactly the same quantum state. Now, quantum state is a technical term, but basically it means have all the same properties. So in quantum physics, you have properties are described by quantum numbers. So one property might be energy. Another property might be speed. Well, Pauli said that you can't have two electrons that have the exact same identities. So if you ask two electrons their identities, kind of like in the army, you're supposed to reveal your name, rank, and serial number. If you ask an electron what its quantum numbers are, it can't give the same answer. It has to have something different. And that is called the Pauli exclusion principle. And the thing that turns out to be different for electrons, if all other things are equal, if they have the same energy, the same speed, everything else is the same about them, it has to do with how they behave in a magnet, in an external magnetic field. If you hold the magnet up to two electrons and they're both otherwise in the same quantum state, one of them must flip up, which is called spin up. The other must flip down, which is called spin down. So they behave like two bar magnets that act differently in the presence of an external magnet. And that it's funny because you don't always know what their spins are. If you don't hold the magnet up to them, they're both in a mixed state of up and down. You don't know what their spins are, in other words. But you hold the magnet up, if one flips spin up, the other one instantly must be flipping spin down. Now, if you separate the particles and you don't measure them at first, if you just don't take a measurement, separate them and hold the magnet up to one and hold the magnet up to the other one, then the same thing happens, even though they're widely separated. One must be spin up, the other must be spin down. And that's remarkable. And that's an example of quantum entanglement, a property that's shared over a very long distance. Now, Pauli turned to Jung during a severe life crisis. So several things happened to Pauli around 1930. First of all, his mother committed suicide a few years earlier because his father had an extramarital affair. His mother was very depressed and sadly committed suicide. Pauli decided shortly thereafter to get married, but the woman he got married to, a cabaret dancer named Katie, was in love with a chemist. And Pauli and Katie got married anyway, but the marriage lasted less than a year because Katie was still in love with the chemist and hardly spent any time with Pauli. And Pauli remarked, had she taken a bullfighter, I would have understood, but such an ordinary chemist, why would she run off with a chemist, he said. And of course, he was a physicist, so that explains his belief. He began drinking very heavily. He began to think that he was hopeless with women, hopeless with getting married. And he wrote to Jung for assistance on the advice of his father, of Pauli's father. And Jung, seeing that his problem was with women, assigned him to a female therapist, his young assistant, Erna Rosenbaum. And Pauli met with Rosenbaum for a few months. And the methodology used in Jungian psychoanalysis is writing down your dreams. So Pauli became quite adept at writing down his dreams. He shared more than 1,000 dreams with Jung and his assistant. So Jung got access to all these dreams, and many of them were full of symbolism. For example, one of Pauli's dreams involved something called the world clock, where you had 4 figures on a clock that was a little bit like the German clocks called Glockenspiels, or clocks where you have little dolls that come out and do a show once every hour. But here, these figures were in a circle, which was inside another circle, which spun around another circle, which was on a bird. So that was his dream, and Jung helped him interpret the symbolism of it. Soon, Pauli considered himself healed. He started drinking less. He met the woman of his dreams, a woman named Franca, and they got married in 1933. And it's interesting and perhaps rather Freudian that if you look at the picture on the left, that was Pauli as a child with his mother. And if you look at the picture on the right, that is Pauli as an adult with his second wife, Franca. And it's a remarkable similarity, I think. In the late 1940s, Pauli and Jung began a collaboration connected with synchronicity, which, as mentioned, is a causal connecting principle. And that, that collaboration had to do with Jung asking Pauli for some information about modern physics, and Pauli giving Jung some answers to those questions, but also finding out from Jung about the idea of archetypes and applying the work of archetypes to the early work of Johannes Kepler, the astronomer, 17th century astronomer, and his contemporary Robert Flood, another astronomer, and looking at connections between symmetry and astrology. Now, symmetry are things like mirror reflection or staying the same under rotation. Pauli was very interested in that from a physics point of view, but there's also applications of symmetry in things like numerology, astrology, and so forth that Pauli became interested in. And in physics, you see symmetry in things like the fact that spin up is balanced by spin down. If you try to connect that with mysticism, that connects in an analogy with works of the Pythagoreans who were interested in numerology, works of the Taoists, such as the Yin and Yang symbol. So, for example, the Pythagoreans, ancient Greek group, thought that 4 and 2 were special numbers of symbolism, and 2 represented duality, and 4 represented a kind of connection between 4 things. And if you add up the numbers 1, 2, 3, and 4, you get the number 10, which was very important for the Pythagoreans. They believed that everything comes in tens, including the planets. So because the Pythagoreans believed that everything comes in tens, they predicted a 10th object in space called the counter-Earth, which turned out to be fallacious. But they also made good predictions, like they predicted that the musical scale would sound harmonious, and that turned out to be absolutely correct. So in studying the works of Kepler, Pauli was interested in Kepler's application of numerology to astronomy, such as this symbol, which was developed by Kepler, which is the 5 Platonic solids, or the 5 perfect solids, put together kind of like Russian nesting dolls, one inside each other. And Kepler thought that he could explain the planets that way, but that turned out to be not true. But Kepler came up with other ways, more scientific ways of describing the motion of the planets. And around the same time, astronomer Robert Flood also tried to develop his own explanation of the planets, and Pauli applied Jungian analysis to looking at both ideas, Kepler versus Flood. In Taoism, there's a Yin Yang symbol, which is also has symmetry in it, and Pauli connected that with quantum physics. And as mentioned in Entanglement, spin up and spin down are always balanced, even if they're objects that are a very far distance from each other. And Einstein called that, as mentioned, spooky action at a distance. And Pauli saw that as a fundamental truth, causal connections that come from symmetry. So they don't come from a causal connection, they come from symmetry. The fact that if one is up, the other must be down. So does this information travel faster than light is an open question, but most quantum theorists think no, because the information comes from the same source, that it's pre-existing information rather than one electron sending a signal to another. Now, the figure here represents an ancient idea by Galileo to try to measure the speed of light using lanterns. And it was an open question for millennia whether or not light has a speed limit. And Aristotle, for example, thought that light traveled infinitely fast. But as it was eventually proven that light does have a speed limit, which means that there's a speed limit for how fast you can send signals from one point to another, which is the speed of light. So Jung and Pauli, collecting all their ideas about synchronicity and about those two astronomers, decided to write a book with two parts called The Interpretation of Nature and the Psyche. One part was Pauli's contribution, which had to do with Kepler and Flood, and the other was Jung's contribution, which had to do with synchronicity. And once that was published, people realized, or most people realized, that Pauli was Jung's secret patient. Because before that, Jung just said that he had a patient who was an expert in quantum physics. Well, of course, that turned out to be Pauli. And Pauli helped Jung to develop a diagram representing the balance of synchronicity and causality. And it's a four-part diagram, since both Pauli and Jung were very interested in the number 4, which, as mentioned, has Pythagorean origins, but there are many cultures where the number 4 is sacred. And in physics, there are things that come in 4s as well as things that come in 2s in quantum physics. So anyway, the 4 things are energy balances space and time, and causality balances synchronicity. This was a diagram that Jung started and Pauli helped finish. So Jung also applied the idea of synchronicity to meaningful coincidences in real life. And an example of that was, he once had a patient that came in, a young woman who dreamed about a golden scarab. And around that time that the patient was talking about the dream, Jung looked at the window and saw a beetle tapping on the window, and linked the two of them and thought that it was more than a coincidence, but it was a meaningful coincidence. Now, that's very interesting, but as it turns out, things that seem rare or a fluke often turn out to be much more common than one might realize. So if you are tuned in to coincidences, if you're tuned into patterns, then you're bound to find them. So if you are obsessed with, let's say, the number 4, and you walk around, you're bound to see many things that come in 4s. And you might call that synchronicity, but it's also a matter of chance. If you were thinking about insects and walk around and you're so attuned to that, you're bound to hear the buzzing of an insect at some point, if it's summertime. And then you might think, oh wow, what a coincidence. But if your brain is tuned into it, then it's actually pretty common for seeming coincidences to appear. Now, Pauli was not only famous for his contributions to physics, and also famous for his temper and his criticisms. Finally, he was famous for a third thing, which was the Pali Effect, and that was his penchant for destroying labs. If he went into a lab, he was a theoretical physicist, equipment would break, and it was very disturbing. And he didn't have to be in the vicinity of the lab for it to happen. He could be far away from the lab for something to happen. And for example, one time he was passing through the German city of Göttingen, and suddenly equipment exploded at the university in the same city for no reason. Another time he was in Princeton, and he was nowhere near Princeton University, but a powerful particle smasher caught on fire around that time and burned for more than 6 hours. So people blame Pauli for that, the Powly Effect. So another example came when Jung opened the C.G. Jung Institute near Zurich, in the village of Kusnacht, and he invited Pauli to attend the opening ceremony. As you see, it's a beautiful building, and would have been a very a delightful ceremony. But then all of a sudden there was a loud crash. A Chinese vase dropped off a shelf for no reason, fell to the floor, smashed into smithereens, and created a huge flood of water. And Pauli immediately sensed the reason. He thought it was the Pauli Effect. And moreover, he was studying Robert Flood, and there was a flood of water on the floor. So he thought, well, that was my fault. And he wrote to Jung immediately and said, well, that was an example of the Pauli Effect, and it must be some kind of synchronicity. Luckily, the Jung Institute remained. It's still there as of this day. And that was a picture of me almost exactly a year ago when I visited the Jung Institute. And I also visited nearby Jung's lakeside home, where he met with Pauli and many others. And I encourage you, once travel is possible, and if you find yourself in Zurich, take the train out to that village, and you can arrange for a tour of Jung's lakeside home, and it's really gorgeous. The property is gorgeous, and the house itself is really beautiful, and you can see his office where he met with various patients. So it was really fascinating. But the reason I didn't take a photo inside is because the rule is no photography inside the building. So I don't have any photos of the study where he met with Pauli. So their correspondence continued until about 1957. And then around that time, Pauli became more skeptical about some of these ideas. One figure that Jung had corresponded a lot with is the American scientist J.B. Rhine, who worked at Duke University and had a lab to explore psychic phenomena, so-called psychic phenomena. And Pauli became skeptical of those results and wrote a letter to Rhine expressing doubts in the existence of the paranormal. But the letter, for some reason, was delayed. We can't blame it on the current head of the post office. It was Swiss postal system, which should have been good. But the letter was delayed, and then it didn't reach Rhine until after Pauli had already died in 1958. But Rhine was really disturbed that Pauli had become a skeptic about his ideas, and Jung reassured Rhine, like, don't worry about it. I'm sure Pauli didn't mean anything by the letter. Now, the place where Pauli died had numerological significance. It was in hospital room 137, and the number 137 has meaning in physics because the inverse of 137, or 1 over 137th, is close to a famous constant in physics, quantum physics, called the alpha constant. So,
just so you know, you have about 10 minutes left. Okay,
well, okay, thank you. So anyway, that was the significance of the room number. That was one of the numbers that Pauli explored. So, question is, what we might learn from synchronicity. Well, synchronicity, as mentioned, is a broad term. It means any kind of a causal connection. So quantum entanglement is, by Jung's definition, a form of synchronicity because it's acausal. So those kinds of things have been measured in many, many different experiments, and they're important in science. So there have been experiments testing using something called Bell's inequality theorem, named after John Bell, proposed it around 1960, testing whether or not a connection is acausal or causal. And many connections have turned out to be acausal. So this is of great significance in quantum physics. So a mystery is, why are some links causal and why are some acausal? So a full theory of the universe should be able to show why there are two different kinds of networks in the universe, why some are causal and why some are acausal. Now, most people, though, in their day-to-day lives, talk about synchronicity as something that happens that seems like it's more likely than chance. For example, let's say you travel to another country and you happen to meet one of your neighbors in another country, which is something that actually happened to me back in the 1980s. I was traveling to the border between Hungary and country that was then known as Yugoslavia. And right on the border at passport control, somebody waved to me. And I said, hi. And they said, oh, I live a block away from you. And it was just complete coincidence. But the fact is that I've traveled to many, many places around the world in my life since then. And there have only been several times in my life where I've run into people that I know just by pure chance while traveling abroad. And many, many, many times when I don't run into people I know. So if I added up all the hours that I logged in other countries and then thought about the moments where I ran into people that I knew and estimated the chance of that, I'm sure it would be more likely than not that I would eventually meet somebody that I know. So, and that happens to anyone. If you travel enough, you're bound to meet somebody that you know at some point. Also, if you go into a room with more than 23 people and you check if anybody shares the same birthday, chances are a group of two people will share the same birthday if you're 23 people or more. And that has been calculated by statisticians. It's called the birthday paradox. If you have 50 people in the room, then it's extremely likely that two or more will have the same birthday. So, and that doesn't seem to make sense. If you were to guess that, you would think you would need at least, 180 something people or so. But that's true if you said, okay, I have a birthday of this. What are the chances that someone else would have my birthday? And then it would be a lot more, a lot less. I mean, a lot smaller chance that people would share one birthday, a single birthday, but the chances that two people would share any birthday is pretty high if you once you go to 23 people or more. So you need to apply statistical analysis to look at any claim before you say, oh, that's synchronicity. So lesson is, if you find yourself on a superconducting maglev train, which operates on the basis of quantum entanglement, as it turns out, and you're having a dream about trains, thank synchronicity for the propulsion system, which is electrons moving in lockstep because of entanglement, not for the coincidence of dreaming about something that in which you're on the same vehicle, because that's something that's pretty likely. So I'm going to stop here, but if you want to learn more about cosmic connections, please check out my book, which is available at bookstores everywhere. If you want a list of links, look at my website, synchronicitybook.com. And that is, it's available on online bookstores and in in-person bookstores, independent bookstores everywhere. So once again, thanks for inviting me, and I will be glad to take questions from anyone.
You commented that the quantum state of things, the entanglement, it doesn't travel faster than light because it is based off of something that pre-existing. do we have any idea what that pre-existing is? And how pre-existing is that? Are we going back to like Big Bang pre-existing, or are we going back to like last week pre-existing?
So that is kind of a controversial point of view. People who say like quantum entanglement doesn't operate faster than the speed of light point to the idea that two electrons, even electrons that are very far away from each other, share the same quantum state. And quantum states don't necessarily have to be localized. Quantum states can be as big as you would like. There's nothing in quantum mechanics that says a quantum state has to be pinpoint. Rather, it can be spread out. So therefore, we say that if you measure one electron that shares a quantum state with the other electron, that information is housed in the quantum state, and that quantum state originated at some point in the past or might have changed at some point in the past. So that's why I say it's pre-existing, because the electrons could have shared that information at any time because they're in the same quantum state. I mean, you can imagine it as, let's say, a long train, and imagine if the train was absolutely solid, and somehow if you tapped on one end, let's say you tapped on the rear train car, the caboose, that the front car, let's say it's the engine car, would instantly move because the train was so solid, so welded together that one thing on one end would affect the other thing on the other end. But that wouldn't be a property of signals traveling. That'd be a question of a solid thing just instantly moving or instantly changing.
Thank you.
Any other questions?
I was wondering, just in general, about how you feel like the state of hard sciences is, in the sense that it feels like we're kind of at this point in our country where science isn't given the value that I think it used to have, or it seems like people are choosing their own set of facts rather than, conclusions. So I don't know if you just could speak to that a little bit about what it feels like in the field and if you've noticed that.
Well, I've noticed, my whole life, or since I've been a scientist, that there've always been people who think, non-specialists and people who, let's say, haven't read up on a subject. So there are some really gifted amateurs who read up a lot on a subject. But let's say there's somebody who's a non-specialist who's never picked up a book on physics or a book on psychology or whatever field they're talking about, and they just go with their gut feelings or their instinctive feelings about something. And, they say, well, okay, here's my ideas about string theory or something in physics, or here's my ideas about the mind. And it's based upon just their gut feelings, which is fine, but that's not science. Science uses, method of, putting out ideas, using peer review to try to figure out which ideas are better than other ideas, using experimentation and so forth. So that has been going on, for decades, for centuries, really, because people have been doing that, throughout history of speculating about things. But I think what's dangerous about today's society is that so much is shared on social media, and then you have somebody advancing their idea, but if they're particularly influential, then a lot of people might share that idea, and it might spread like wildfire throughout the world. And even if it's refuted, a lot of people might believe in that idea. and maybe might even believe in it more than they believe in a scientific idea. So that's pretty scary. And, scientists have to work very hard to emphasize the scientific method, to emphasize facts and so forth. But increasingly, scientists are up against people sharing pseudoscience on social media. And, one needs all the time fact checkers to say, well, that's false. So that's, I don't know what to say except that if I see something on social media, I'm very active on Twitter. If it's completely inaccurate, I try to dispute it if I think I can convince people. But sometimes there's no convincing people. On Twitter, I have, for some reason, I was tagged on a thread in Twitter of climate change doubters. And there was somebody on the same thread who was a climate scientist who knows a lot more about it than me, who put links to research articles in very prestigious journals talking about the effects of human-caused climate change. And then the people in the thread who doubted climate change basically said, oh, well, all those scientists are being bribed, they're being bought out, you can't believe anything they say. So what do you say to people who doubt science itself? It's very hard to dispute that.
They just want to be right.
I think Mary Ellen would like to make a comment about a future ethical society event. So maybe, Travis, we can stop at this point.
Okay.
Yeah, that sounds good.
I wish you hadn't done that.
Okay. Well, thank you.
Thank you very much.
Thank you.
Thank you.
As a teaser.
Thank you.